Good morning, everyone. So welcome to my YouTube channel, Maths Uttanam. So today we are going to see second lecture on Riemann integration. So let's start session now. So note one thing. Let F closed interval AB to R be a bounded function. Okay. Then a small m times b minus a is less than LPF is less than equal to UPF less than equal to m times capital M times b minus a for any partition P of closed interval AB. Okay. So let's see its proof, how it works. Let P is equal to AX naught less than X1 less than X2 and so on Xn minus 1 less than Xn, that is B. Okay. Be a partition of closed interval AB. Okay. Then small mi is less than mi, that is less than capital Mi, that is less than capital M. Okay. So this implies I can multiply by delta xi. Okay. Now take summation. Now taking summation both the sides. So this implies summation. So this is true. So this is true for I goes to 1 to n. Okay. This is also true for I goes to 1 to n. Okay. So taking summation m delta xi I goes to 1 to n mi delta xi less than summation I goes to 1 to n m capital Mi delta xi less than I goes to 1 to n m delta xi. Okay. So you take m common here. If you will take m common here, then what will be this? Delta xi. Okay. And what is this? This is LPF. And what is this? This is UPF. This is UPF, this is LPF, and capital M will be come outside. So what is this? This is B minus A. So what is this? M times B minus A is less than LPF is less than UPF. Okay. It's less than M times B minus A. So this is true. This is proof. Okay. So now I am going to prove a theorem. Let F close interval a b to R be a bounded function. Okay. And P1, P2 be two partitions of closed interval a b. Then number one, then first case, if P1 is contained in P2, then L, then U, P2 F is less than equal to U, P1 F. Okay. Second is, and U, P1 F, sorry, L, P1 F L, P1 F is less than L, P2 F. Okay. Second one is L, P1 F is always less than L, P2 F, less than M times B minus A less than equal to capital M B minus A. So let's prove it. Okay. Okay. So assume that P1 is contained in P2. It means P1 is subset of P2. Okay. Now, assume that first we assume that P2 is nothing but P1 times P1 union Y. Okay. It means P2 contains only one more point than P1. Okay. Then what will happen? So I am saying that okay. So also consider. So P1 is partition. It will look like A is equal to X0, X1, X2. Xn minus 1. Xn is equal to B. Okay. And Xi minus 1 will be there. Then Xi will be there. Xn minus 1. Xn is equal to B. Okay. Okay. Now what will be P2? P2 is nothing but P1 union Y. So it will be somewhere. Y will be somewhere. Okay. So Y will be somewhere. Okay. What does it mean? It means you have a closed interval A and B. So X0 point is this. X1 point is this. X2 is this. Okay. So somewhere Xi minus 1 is there and Xi is there. Then Xn minus 1 is this. And finally Xn is this. So Y is somewhere here. Okay. So let capital MI, capital MI 1 is equal to supremum of Fx, where X belongs to Xi minus 1 Y. Okay. Mi2 is supremum of Fx, X belongs to Y, Xi. Okay. And small I1 is infimum of fx, x belongs to xi minus 1 y, and mi2 is infimum of fx, x belongs to y xi. Okay. Okay. Now tell me. Now, since x I minus 1 and y subset of x I minus 1 xi. Okay. And y xi is contained xi minus 1 xi. Okay. When you have a smaller set, the supremum is smaller set is always less than supremum of bigger set. So what will be this? Then what will have? Then the supremum here, what is that? Mi1 will be less than capital Mi, because Mi is supremum in this. Okay. And Mi2 similarly will be less than Mi. Okay. Similarly, okay. Similarly, infimum of a smaller set is always greater than infimum of a bigger set. So what will be this? Infimum increase. If you take infimum of a smaller set, that will be greater than infimum of a bigger set. So what we have? We have small mi is less than small mi1 is greater than equal to mi, because infimum increases, and mi2 is greater than small mi. Okay, we will use these two facts. Now, next, what is UPF, UP1F. What is this? This is summation I goes to 1 to n capital Mi delta xi. So I can break it. So this is M1 delta x1, M2 delta x2. Okay. So what is this? Mi minus 1 delta xi, and then Mi delta xi plus then Mi plus 1 delta xi delta xi plus 1 and so on, plus last is Mn delta xn. Okay. Now I can write okay. So let this equation number 1. Now What is mi delta xi? I can write this. What is mi delta xi? Xi minus xi minus 1. Okay. So this can be written as mi xi minus y plus y minus xi minus 1. So this can be written as mi xi minus y plus mi y xi minus 1. I can also write like that, y minus xi minus 1 plus mi, okay, xi minus y. Okay. Now, what is this? You can say this I am denoting by this one, xi 1, and I am denoting this difference xi 2. But on this interval, y xi minus 1 to y, the what you have this is smaller, mi 1 is smaller and mi 2 is also a smaller quantity. By adding this you will get it. So what you have? So this is mi. So write in next line. So you have mi delta xi is less than mi1 delta xi 1 mi2 delta xi 2. So from 1 and 2 what we have? From 1 and 2 we have UP1F, that is summation I goes to 1 to n mi delta xi. What is that? m1 delta x1 m2 delta x2 plus mi minus 1 delta xi minus 1 mi delta xi plus mi plus 1 delta xi plus 1, okay, plus mn delta xn. But this quantity is less than, from equation number 2 what you have? This quantity is less than mi1 delta x1 xi1 and mi2 delta xi2, okay. So from 1 what you have? You have this one, m1 delta x1 plus m2 delta x2 mi minus 1, okay. Delta xi minus 1 plus mi delta xi plus, okay, this is what? 1 mi2 delta xi 2 plus mi plus 1 delta xi plus 1 plus mn delta xn. Okay. So what is this? What is this actually? This summation I goes to 1 to okay. What is this? This is nothing but what is this? This is UPF and partition is P2. This is P2. Okay. So what you have? You have U P2 P1F is greater than U P2F. Okay. So this implies U P2F is less than U P1. Okay. Let's say this equation number. Okay. So this one we have to. Now also what is L P1F? What is this? This is summation I goes to 1 to and mi delta xi. Similarly, we can open this m2 delta x2 and it will be mi delta xi mn delta xn. Delta xn. Okay. Now, what is this? What is this? Let's say this equation number 3. Now, mi delta xi. How can I write this? This is mi. What is this? Xi minus xi minus 1. So I can add and subtract y. Similarly, okay. Now, how can I write this? I can write this mi y minus xi minus 1 plus mi xi minus 1. Okay. But small mi is less than mi1 on this interval xi minus 1 to y. So I am calling this difference delta xi1. mi2, I am calling this difference xi2. So what we have? mi delta xi is less than mi1 delta x1 mi2 delta xi. From 3 and 4, from equation 3 and 4, what we have? From 3 and 4, we have LP1F is equal to summation I goes to 1 to n mi delta xi, but after opening this one, m1 delta x1 plus m2 delta x2 and so on, mi delta xi plus mn delta xn. But this by equation 4, this is less than equal to this. Okay, so case value है plus m2 delta x2 plus mi1 delta x1 mi2 delta xi2. Okay, plus and so on m and delta x. Now what is this? This is nothing but LP2F. Okay, so what we got? We got LP1F is less than equal to LP2F. So this case is done when P2 is contain one more point. Okay, this was case number 1. Okay, but P2 can contain more points. So this was case number first. Let's say in starting, this is case first. Then P2 interval contain one more point. Now case 2. Case second. Then P2 contains more than one point than P2. T1, sorry. Okay. In this case, suppose because P2 contains more than 1 point than P1. So suppose P2 contains m number of more points than P1. So in this case, how it will look like? So P2 will be equal to P1 union Y1, Y2 up to Ym. Okay. Put Q1 is equal to and put Qj is equal to P1 union Y1, Y2 up to Yj. Or J is equal to 1, 2 up to M. Then what we have? then P1, okay, P1 is contained in Q1. This Q2 contained in Q1 contained in Q2, and so on. It is going Qn, okay, contained in P2. Okay. Sorry, I am taking it up to m minus 1. I am taking this up to m minus 1. Okay. So Q m minus 1 Q m minus 1 m minus 1, and last one is P2. Okay. Where Q j plus 1 is equal to Q j union y j plus 1. Okay. So I am writing here A. It will be then both. So this will be Q j Q. Sorry, I should write here. So this is Q j plus 1 is equal to Q j plus 1. Okay. For j is equal to 1 to m minus 2. Okay. And what is P Q1? Q1 is nothing but P1 union Y1. Okay. And what is P2? P2 is nothing but Q m minus 1 union Y m. Okay. Y m minus 1 Y m. Okay. Now you observe that Q1 is Q1 is superset of P1 that contains one more point than P1. Okay. And Q2 contains one more point than Q1, like that. So next Q1 contains one more point than previous Qj. Okay. And P2 contains one more point than Q m minus 1. So why? So therefore we have following the proof inductively as above. Following the proof inductively as above, we get what we get. We have already proved that if some partition contains one more point than other partition, okay, what is the relation between LPF and UPF? So UPF decreases and LPF increases. Okay. So what is UPF here? So what we get? What is UPF P1F, that will be less than Q1F, but Q2 contains one more point, so then it will be Q2F. Okay, then it will be continue. Okay, this will be U2M minus 1F, and that will be finally less than UP2F. So by this, what we will get? P1 is less than, UP1 is less than this one, then this is less than. So this implies UP2F is less than UP1F. So what we got? We got this one. Similarly, we have LPF increases. So LP1F will be less than LQ1F, and that will be less than LQ2F. It will follow that will be less than LQM minus 1F, and finally it will be LP2F. Okay, by this what we will get? This will be LP1F is less than LP2F. Okay, so finally, hence for any partition P1 and P2 of AB such that P1 is contained in P2, we have what we have? UP2F will be less than UP1F. Okay, and LP1F will be less than LP2F. Okay, in upper sum decrease when partitions increase, number of points increase, and lower sum increases when number of points increase in partition. Okay, so what we have? We have this one. Now prove second one. First part of this theorem is proved. Now second one. Now second. Okay, let P1 and P2 are partitions of AB. Put P is equal to P1 union P2. Okay, now P1 is contained in P2, P1 P, and P2 contained in P. Okay, so I will tell you this later. First, You observe one thing. So P1 union P2 is also partition. P1 union P2 is also partition. So union of two partition is also partition. So this is partition of closed interval AB. Okay. So this is also partition of closed interval AB. By note of this lecture, we have written a note in the starting of this lecture. We have LPF is less than UPSC. Let's say this equation number 5. This follows from note, because LPF is always less than UPF, that is less than capital M times B minus A. And LPF is less than M times small m times B minus A. So we are taking middle things only. Okay. Okay. Now P1 is contained in P and P2 is contained in P. From part first of this theorem, we have LP1F will be less than LPF and so LP1F will be less than LPF. Okay. And UPF will be less than UP2F. Because let's say this equation number, we understand it again. Because once a partition is lesser than other partition, if you are taking lesser partition which has less number of points, okay, then suppose you have two partitions. Now P1 is partition, P is partition, P1 is contained in P. Then lower sum always increases and upper sum decreases, because P2 is contained in P, so it will decrease because the upper sum corresponding to larger partition will be less than upper sum corresponding to smaller partition. So this is equation number 6. Okay. Now again applying note of this lecture, we have what is M times B minus A will be less than L P1F. Okay. And U P2F will be less than capital M times B minus A. Because by note, you take any partition. I am replacing P by P1 and again I am replacing P by P2. So apply notes for this. Small m B minus A will be less than L P1F and U P2F will be less than M times B minus A. Let's say this equation number 8. Okay. 6, sorry 7. This is equation 7. And this is equation number. Okay. Now from 5, 6 and 7. From equations 5, 6 and 7, we get, okay, what we get from equation number 5, what we have? LPF is less than UPF. But by equation number 6, UPF is less than UP2F and LPF is less than LP1F. But by equation number 7, we have this one. This is less than M times B minus A. But by again equation number 7, we have this one, M times B minus A. So what we have? We have M times B minus A is less than LP1F is less than UP2F, that is less than M times, capital M times B minus A. Okay. So this is the proof. Okay. So this is for any partitions P1 and P2 of closed intersection. So this is done. The proof of theorem is done. So I would like to write a remark. Okay. Let F closed interval A B to R be a bounded function. Okay. And P be any partition of closed interval A B. Then we know that LPF is less than UPF. So if something is less than equal to this implies LPF, either they are both equal or they are, LPF is strictly less than UPF. So this is one. Either they will be, because it is less than, either this will be equally, there will be equality, or there will be LPF will be strictly less than UPF. That is why in previous lecture I told that either LPF is equal to UPF or LPF is not equal to UPF. Okay. Okay. So today's lecture up to this. If you have any problem related to this, you can comment me on my YouTube channel. So thank you much for today's lecture. Like, share, comment and subscribe my YouTube channel. We will meet you in next lecture. Thank you very much.